Hey guys, okay, so you'll notice up top here that I have all this interesting information for you. And the nice thing about it is that I am going to be able to show you how to go about, let me just move this over a little bit so we can see it better, how to go about starting off with a data point, finding its z-score, getting its value, but then knowing now what we know, that you can start with a percentile, go back to get the z-score, and then go back to find out what that data point is. So we should know how to go from here to here, but I'm going to show you how to go from percentile to z-score to data point, because it's all a process of how you get from somewhere to another. You're going from here to here. It's showing you that you have to pass through certain places to get to others, which I think is important. So let's start with this problem. You have the average weight of a football player in the NFL is 250 pounds with a standard deviation of 25 pounds. If you look below, you will actually see that I have done everything out. I put your z-scores in, I put the percentiles in, I put it all in, I broke down what your percentages are going to be and so forth. So it's really nice because it's all set up. So now my first question is, if I said to you, what percentage of players weigh between 225 and 275? What's nice for us that it's right here. 225 to 275 represents all of this area in here, which will be 34% plus 34%, which is 68%, which you guys should recognize is the middle 68% of that empirical rule that we've always talked about. Now, what's cool is that before, like if I said to you, what percentile would somebody who weighs 230 pounds, what percentile would somebody who weighs 230 pounds fall in, right? What is his percentile? That's what I'm trying to find, his percentile. So if you recall, the first thing we would have to do is, here's your percentile, right, that we're going to be looking for. So data point is our 230 pounds. So to find out what the percentile is, the first thing we need to do is get the z-score, which you should know. And to find the z-score, we do z equals that the weight minus the average weight divided by the standard deviation, which we know is 25. So, you know, z would be equal to 230 minus 250, right, over, there goes the lights, but who cares? What am I going to do about that? Over 25. So this would give us a negative 20, is that right? Negative 20 upstairs. So this would be negative 20 over 25, which I'm going to say is negative 4/5. So my z-score is equal to negative 0.8, right? So if I want to find out what the percentile is for that guy, I have to use my norm thing here, where my ZL is my left z-score, ZR is my right z-score. So if somebody weighs 230 pounds, they're going to be somewhere in here, and I want all the area back there. So if you recall, I do my norm, CDF, but then we use that negative 999, comma, negative 0.8, and we go into our calculators and punch this in, which I'm going to go do right now. So I'm going to hit my second distribute, and number 2 is my option, and I'm going to type in negative 999, enter. My upper is negative 0.8. Come on, 0.8. Gonna scroll down, scroll down, paste it in there, hit enter, and it would be 21%. So the percentile is, we are at 21%. So let me just go find out where the heck I'm supposed to be going here. Okay, so this is equal to 21%. So the 21st percentile. So if you weigh 230 pounds in the NFL, that means that you weigh more than 21% of the other guys who play in the NFL. Okay? Now, so if, let's say you wanted to find out what percentile somebody who weighs, somebody who is in the, let's say the 71st percentile, okay? If you're in the 71st percentile, we're trying to find out how much you actually weigh. So now we're given the percentile, but we got to work our way back to what the actual weight is. So if you look over here, if I say the 71st percentile, if you look here, I'm going to say that that person is going to weigh somewhere between 250 and 275 pounds. So the first thing that we have to do is we have to figure out how to go and get the z-score for what the 71st percentile is, and then we can plug it into this little formula over here, which is basically solving this guy for x. So the first thing that I'm going to do is I am going to hit pause, so I'll be right back. Okay, so I'm back, And the thing we want to do is we're going from a percentile back to a z-score back to what a person weighs in the 71st percentile. So if you look over here, I have in here, it says inverse norm percentage, but you have to put it in decimal form. So on your calculator, there's a key there called inverse norm, like we were able to find norm CDF. It's in that same spot. What we're going to do is we're going to type in inverse norm, but we're not going to put in 71. We're going to put 0.71 in because it has to be the percent. So we're going to type in, in our calculators, we want to do inverse norm, and we're going to put 0.71 in here. And what this is going to give us is our z-score, okay? So let's go in here to our calculator. Come on. And this time we're going to do inverse distribution, and this time you'll notice number 3 is what we're on the hunt for, okay? And the area we're looking for is 0.71, okay? And we were just going to scroll down and we're going to paste it in there. And when I do that, that means that my z-score is 0.55, okay? My z-score. So I'm going to go back in here to my little workspace. So this means that I have a z-score of 0.55, okay? Very important. It makes sense it should be, because if you think about it, you're looking for the 71st percentile. 71 is between 50 and 84, right? And your z-score is going to be between 0 and 1, which is 0.55, so it makes sense. Everything is falling into place quite nicely. So now I'm here at my z-score. My goal is to now get back to that particular data point that I'm on the hunt for. If you look over here, I have z is equal to the data point minus the mean divided by the standard deviation. If I want to solve for this guy, the first thing I do would be multiplying both sides by the standard deviation, and then I would add the mean to both sides. So this is basically telling me that if I solve this out algebraically, I'm going to get this. So if I want to find out what x is, which is how much a guy weighs who is in the 71st percentile, all I'm going to do now is I know that my mean is equal to 250 and my standard deviation is equal to 25, okay? So what I'm going to do now is I am going to go ahead and plug everything in here. So now I know that x is equal to the z-score, which is 0.55, times the standard deviation, which is 25, and then I'm going to add the mean, which is 250. So x is equal to, and we're going to come over here. Or actually, I'm going to do that on my calculator. You guys do it on yours. I'll be right back. Hi. So I got 263. Whoops. Where are you? So I got 263.75 pounds. So a guy who is in the 71st percentile is going to weigh 263.75 pounds, and it makes sense because he's going to be right in here. Okay? All right. I'll be right back. Okay. So let's say the next thing we want to ask to make things a little more interesting for ourselves is, we want to determine what weights fall in the middle 60% of the data. Well, we know that from here to here is 68% of the data. So we want, or 68% of the weights, let's just really start talking about what we're talking about. But I want the middle 60% right from here to here. So 60% would go from here, about from here to here would be 60%. So the first thing you need to do is identify, I'm going to use a new color here so it's easy to follow, is that 60% I'm going to say is probably right over here from here to here. So this is about all of this area shaded in here. So now what we need to do is we need to figure out what the percentiles are that these fall between. Now, if you remember, everything is based on 100%, which is kind of cool. So we know then if this is 60%, 100 minus 60% is 40%, and half of 40% is 20%. So that means on this side, this is 20% of the data is going to fall on the outside of this, and out here is going to be the other 20%, which means if you look over here, this that we're looking for is actually the 20th percentile. I'm going to write this in another spot in another color. Okay, so this right here is the 20th percentile. So we know that the middle 60% is the 20th percentile to 20th percentile to the, now think about it, if this is 80% above that, I'm sorry, if this is, I just gave you the answer, I didn't mean to do that. If it's 20% above, that means that it's going to be 80% below, so therefore this is the 80th percentile. Okay, so this is the 80th percentile. So the middle weights are going to be between the 20th percentile and the 80th percentile. So the first thing we need to do now is, like we did before, is we got to find the z-score for both, right? We got to find the z-score for both of them and then go from there. So if we have the 20th percentile, that means that we have to get the z-score. This is a mess over here what I did earlier, so I'm just going to try to move this out of the way because it's driving me downright crazy. Okay, so going back to my little pen over here. So for the 20th percentile, right, again, we got to do that inverse norm for 0.20. We also have to do the inverse norm for 0.80. So we're going to go do those now. So we're going to go back into our calculator, and we're going to do second distribute, and we're going to do number 3. And the area we want this time is 0.20. And enter, enter. And it's negative 0.84. So the z-score for our 20th percentile is negative 0.84. Okay, let's do the other one. We may as well take them both. So I'm going to do second distribute. And then again, we're going to do the same thing, but this time we're going to do it for the other guy. Oops, go back up. It's going to be 0.80. And scroll down, paste, paste, paste. And it's 0.84. So they're exact opposites of each other, and it makes sense because there is a little bit of symmetry going on there. So if I go over here, this is negative 0.84, and this is positive 0.84. Now let's talk about why they make sense, okay? Why these z-scores make sense. If you're in the 20th percentile, right? If you're in the 20th percentile, that means then that you are somewhere over here, and if you look down, that means you're in between -1 and 0 z-scores. So you should be a negative 0.84. You should be in between there. And then if you're in the 80th percentile, which is right about here, that means you're between 0 and 1 z-score, which means that you should have a 0.84, so it does make sense. So now for this guy, what we're going to do is we're going to bring him down, and we're going to find out. Now remember, this is the z-score, so to go back to find out what that weight is, we got to go back this away. So what we're going to do is we will do that our x is equal to our z-score, which is negative 0.84, times our standard deviation, which is 25, plus their mean weight, which is 200. Okay? Stop. All right? And then, so this one down below is going to be a similar one, and this is going to be x is equal to positive 0.84 times 25 plus 250. Okay? I'm going to go get those answers, and then you can go ahead and get them too, and I'll be right back. Okay, so the first one, I got x was equal to 229 pounds. And the other one, I got x was equal to 271 pounds. So if you're in the 20th percentile, you weigh 229 pounds. And if you're in the 80th percentile, you weigh 271 pounds. So it's saying what weights fall in the middle of 60%. It's if you weigh 229 pounds and 271 pounds represents the middle 60%. And it should make sense because the middle 68 is 225 to 275. So the middle 60 should be in between, should be in between those two, which is 229 and 271. I hope these have proven helpful to you. I'm going to be assigning problems, and yes, I am collecting them. And yes, I'm going to add this to your test. Good luck.